Globe illusion. It says if, or it says according to the heliocentric model, or something. There's kind of this missing implied bit here. If the Earth is on one side of the Sun, and in one time of year, and the opposite side of the Sun at the opposite side of the year, I don't know what he's got against people from Crete. Honestly, it's a nice enough island. Sure, they get drunk and shoot road signs, but everyone's got some kind of weird hobby. Anyway, I'm going to do exactly what that button there says. Once I remember to screw this thing onto the bottom of the camera so I can actually mount it on the tripod. Oh, yeah, I just have to change batteries and I have to take this off to do that. And I've got to screw it back on. There we go. I'm going to reply not using that. Sorry, I'm saving that for when little Miss Oakley comes around and asks for protection. I'm going to reply using a boring old piece of paper. There. I know it's tempting to use coloured chalks or crayons or something, but I'll just use a biro. Here's hoping it's all on screen, right? Now, you may be familiar with this question because you may have seen doodles of the Earth's orbit around the Sun with Polaris up there, and kind of it's that way and it's that way. Or if they're a little bit smarter, you know, they point in the same direction from both sides. What they fail to understand is that if that's the Earth's orbit around the Sun, Polaris is actually up this way, about 23.4 degrees from the plane of the piece. Yeah, from the plane of the piece of paper. Because the Earth's axis of rotation is pointing roughly at Polaris and about 23.4 degrees from the plane of its orbit around the Sun. And what he's saying is that in summer you'd be looking at these stars out here, and in winter you'd be looking at these stars out here. And he's right. That is what happens. But that's only specific stars. You don't see these stars when you look up at night in summer, and these stars when you look up at night in winter. If you are on the Earth somewhere out here with a curved surface, because it's a globe, an oblate spheroid, and you're about 45 degrees or thereabouts north of the equator, you can see that direction, and out there, and straight up, and up that way. And assuming the Earth is orbiting this direction, not round on the paper now, Polaris due north of you, we have the celestial equator, which I can spell, which is sticking out this way. The lead star of Orion's belt, and generally the zodiac, lead star of Orion's belt is on that. Orion's belt and the zodiac are generally around it. That's stuff that is directly overhead at the equator. It is your latitude away from directly overhead, wherever you are. This is overhead, and what's directly overhead will depend on your latitude and the time of year. And this is some kind of southern stars. Same curve, it's the exact same curve, the exact same size and everything as that. Honest governor, I'm that good an artist. But you're standing in Australia, 30 degrees south, 4 o'clock position. Overhead is those southern stars, which are overhead home stars to you. You can still see the celestial equator, but it is 30 degrees north of overhead. There's the terrestrial equator. And from there you can also see Sigma Octantis, which is somewhere near the celestial South Pole. You can see past the celestial South Pole to look beyond where the Sun is. And if you've seen my diagram of the scale of the solar system, you'll know that the Sun in this case is like across the road that way somewhere on this scale. And you can see up here north of the celestial equator towards what will be overhead for this guy in the north. Come round to the other side of the orbit, vast amounts of space here. Absolutely enormous Sun. Vast amounts of space here. On the other side of the Earth, whether you're up there looking at Polaris and looking back past the sun at the stars that were overhead here, if you're 60 degrees north, which is quite a long way north, 55 degrees north, somewhere in Scotland or Canada or bits of, I don't know, the Baltics, Russia, maybe Japan, you can see here above the northern horizon what was overhead the opposite time of year. And you can see overhead, my wonderful handwriting, I should have been a doctor, what was just above the northern horizon at the opposite time of year. You can also see the celestial equator and you can see southern stars. Oh no, he wrote SS, he must be a Nazi, shoot him. Or if you're in Australia, you can see those stars near the northern horizon. You can see, that was a good line, the celestial equator. Can't bother writing out in full. You can see overhead here, and you can see, why am I bothering to write sigma octantis when I could just do sigma and then 8? There you go, sigma octantis. And of course you can see very slightly past the sun towards other southern stars. Let's call them other side southern stars. So I said being able to see completely different stars is what's happening, and it is. The stars around that part of the celestial equator that you can see at that time of year, and the stars around this side of the celestial equator that you see at this time of year, are completely different. And which ones you see will depend on, think about this, will depend entirely on the time of year, where the Earth is in its orbit around the Sun. So Orion is on one part of the celestial equator, and it is a November to March-ish kind of, September to March, something like that. Anyway, it's a winter constellation. One of the reasons it's so famous is that it's there when the nights are very long. And when people are still up and about and outdoors and active after it gets very dark, so it's visible. People look up and see it. The summer celestial equator constellations, they're only visible if you stay up till like midnight in summer on a clear night after you've been out for a barbecue or something and happen to look up at the celestial equator. They're probably less familiar, but there are constellations all the way around this way and down there that way around the celestial equator that are each visible. See, they set earlier and earlier, so they rise earlier and earlier. So they're during the day, and then they're in the very early morning. Then they're overhead in the middle of the night. Then they're overhead in the evening, and they stop being visible overhead because it isn't dark enough to see them yet. You can just see them just as they set. In the case of Orion, you can go out just after it gets dark and look west and see Orion setting in spring. And in summer it's already down by the time it's dark enough to see it. It's overhead behind the sun in the middle of summer, or whatever time it's at its zenith at midday, whatever time of year that is. It's overhead, but it's out of sight behind a whole lot of sunlit air and the sun itself. And then come autumn, it's rising just after dark, so the sun goes down and you see Orion come up, and the whole time around at night Orion is getting higher in the sky. It's one of the reasons it's so familiar. So you are seeing different stars in summer and winter. Now, depending whether you're in the northern or southern hemisphere, summer could be one side or the other. You could say this is summer for the southern hemisphere, this is summer for the northern hemisphere, winter southern, winter northern, or vice versa. I mean, I haven't defined it really here. If Orion's that way, then this is northern winter, southern summer. You know what I didn't do? I don't include 23.4 degrees of tilt. Let me just check whether that paper's still central. Let me just check that. Top left, top right. Yeah, good enough. Just draw it in the middle of the paper, we should be fine. Not to scale. Sun. Earth with a tilted axis, Earth with a tilted axis. Polaris is off that way, a very long way. So this is December, or winter anyway. Orion is somewhere out there, and no, it isn't. Orion. Well, his belt is down here. Orion's actually a pretty big constellation, so his shoulder is probably somewhere up there, and his foot is somewhere down there. And over here, at right angles to that rotation, axis of rotation, you have, what the hell? Celestial theta, celestial equator stars, opposite Orion's belt, whatever they are. Polaris is the same direction in both cases. Sigma Octantis is the same direction in both cases. Tiny change, tiny change in angle. It's like some fraction of a degree. For close stars, if a star was really close, obviously you would get considerable change in angle. But when you're talking about something like Polaris, 400 light years away, 8 light minutes, the angle don't change much. So when that illusion guy said you should see completely different stars, well, you do, if you're looking at the celestial equator. If you're looking true north or true south, you're going to see the same stars. Assuming you're in a place on the Earth where you can see stars, true north or true south, which is anywhere outside the tropics, you're going to see the same stars, true north and true south. If you're standing on the North Pole, what the hell are you doing spending a year on the North Pole? But if you did spend or make a lot of visits to the North Pole, you would consistently see the same stars directly overhead no matter what time of year it was. Likewise the South Pole. For people living 50 degrees north, directly overhead is going to be, I don't know whether Betelgeuse is 40 or 45 or 50 degrees north, but it's going to be Betelgeuse at some point. It's going to be other stars there. And if you're there, you have sort of a this angle where you can just see Polaris, and a this angle where you can just see Sirius, just see below Sirius. You can see all of this. From here, that same latitude would give you that angle and that angle, and you can see all of this. Where these two angles overlap, any star that is in any of these directions from Sol is going to be visible year round. But the stars that are out this way and this way, they're not. Those are the ones that are different year round. All in all, the basic reason that question might confuse someone of why you should be seeing different stars at different times of year, but you can see the same stars all year round, it's 3 dimensions. And I can't really draw in 3 dimensions on a flat sheet of paper for you, but I tried to describe it. The stars you see that are different depending on the time of year are around there. The stars that are the same year round are there and there. I hope that helps clear it up.